Here we have a couple of dimensional analysis problems like those you'll find during your first day of lab. Although these problems aren't really chemistry, dimensional analysis is a process that is used in chemistry quite regularly, so practicing with it is very important. If you've worked with Alex at all over the summer, or since classes have started, you may already have some experience with similar types of problems. So let's go over them. It says if a runner runs a 5-kilometer race, a 5K, how many miles did she run? The required equality is 1 mile equals 1.61 kilometers. So we have the equality 1 mile equals 1.61 kilometers. Starting with 5.00 kilometers times. When we're doing dimensional analysis, we want to convert two equal things into what is called a conversion factor, which essentially means you write them as a fraction. You want to get the unit that you want to cancel out on the bottom of your conversion factor. So here we want to put 1.61 kilometers on the bottom so that kilometers will cancel out. And then we want to put 1 mile on the top. You're always going to have two equal things. One will go on the top and one will go on the bottom of the conversion factor. You always put the one on the bottom that you want to cancel out. So now kilometers will cancel out. When you do this, to mathematically multiply by the top and divide by the bottom, the calculator will tell you 0.10559 and some more numbers. The calculator often doesn't get the significant figures correct, but here we have two measurements, 5 kilometers and 1.61 kilometers. Both of these are three significant figures. These zeros do count because they're after a number and a decimal place, so our answer should be three significant figures, which is 3.11 miles. So a 5K race is 3.11 miles. Notice that these things are exactly equal. If someone runs the 5K, or if someone runs 3.11 miles, they've both run exactly the same distance. Or if an individual person runs 5K, they've run 3.11 miles. The reason this works is because these two quantities are equal. Two equal things divided by each other mathematically cancel out and become 1. Any number times 1 is itself. So even though the number changes from 5 to 3.11, the quantity didn't. 5 kilometers is exactly 3.11 miles. That is the whole point of dimensional analysis, which you will use repeatedly in the chemistry courses. All right, the next question. It says a baseball travels at 13 meters per second. How many meters will it travel in 42 seconds? 42.0 seconds. So here we need to take the number of seconds and convert it to a distance. To do that, we're going to need an equality. In the first question, we were explicitly given the equality. Here, in this question, we have to come up with it ourselves. The equality that we're going to come up with is based on this unit, 13 meters per second. That means for every second the baseball travels, it moves 13 meters. Said another way, 13.0 meters is exactly equal to 1 second. Now, starting with 42.0 seconds, it's very similar to the first problem. Now we have to put one of these things on the top and one on the bottom. We want to put seconds on the bottom because we want seconds to cancel out. And we put 13.0 meters on the top. Multiply by the top, divide by the bottom, and in this case you get 546 meters, and just by coincidence your calculator gives you the correct number of significant figures. So that was lucky. All right, let's look at the last one. The last one is multiple step, but it's the same idea. It says, if grapes cost $1.99 a pound, per pound, how much would 1,250 grams of grapes cost? Well, here we have $1.99 per pound, so $1.99 equals 1 pound. However, we have a gram of grapes. So before we can use this as an equality and then as a conversion factor, we do need to convert this into pounds so that we can use it. And it turns out that 1 pound equals 454 grams. Now we wouldn't expect you to have this memorized. In the lab, we would give you this equality, but here I'm giving it to you now. So 1 pound equals 454 grams. That's the first equality that we need. But we need a second equality because we want to know how much they'll cost, how many dollars they're going to be. And we have this, $1.99 per pound. $1.99 equals one pound. So $1.99 equals 1 pound. Excuse me, making a mistake there. But these are basically our equalities. So starting with 1,250 grams times, what do we want to put on the bottom? Well, on our first equality, we have 1 pound and 454 grams. Since we want grams to cancel out, we put grams on the bottom in the denominator, and we put the 1 pound on the top, or in the numerator. Then we need to do another conversion because we don't want to know how many pounds this is. We want to know how many dollars this is going to cost. In this case, we use the second equality. To do the second conversions, we need a second equality, and we have one. So in this case, we want pounds to cancel out. So we put 1 pound on the bottom, and we put the $1.99 on the top. When you do that math, multiply by the top, divide by the bottom, multiply by the top, divide by the bottom. No, if the number is 1 pound, which it is here and here, you don't actually need to type that into your calculator. But when you do that work, you get $5.48. And here, money isn't really a measurement exactly, so we usually round to the nearest cent. So we're just going to round it to two significant figures. I did use 3 sig figs in all of them, but here you might round to the nearest penny. It's not super important. That does not come up in the chemistry class very often. So you will be doing some problems like this on your homework and in the lab.